So we're going to take a look at using the chi-square distribution table to find critical values. And we'll be using just this first page of the table, A4, and what we'll always be using is just this one column. Oops. That's with the area on the right of the critical value 0.05, so that significance level of 0.05 that we'll keep using. Here we have degrees of freedom on the left, and just as a reminder at the bottom here, the two situations that we'll use this table is for goodness of fit tests, and our degrees of freedom will be k-1, where k are the number of categories, and for contingency tables we'll have r-1 times c-1 when the table has r rows and c columns. And I'll show you what that means. So for example, if we have we're doing a test for independence between gender and political affiliation, we've got our data table right here. It has 2 rows and 3 columns. So rows equals 2, columns equals 3, degrees of freedom is r-1 times c-1, which is 1 times 2 for 2 degrees of freedom. So if we're trying to come up with a critical value for doing a chi-square test for this particular table, we've got 2 degrees of freedom, and in our table we'll see for 2 degrees of freedom our critical value is 5.991. So if we had a table like this, we're doing a chi-square test for independence, we've got 2 rows, 2 columns, of a standard 2x2 table. Degrees of freedom is going to be r-1, c-1, which is 1 times 1, which we all know is 1. So for this test, our critical value would be 1 degree of freedom, 3.841. That's your critical value. So those would be for the chi-square test for independence. And down here at the bottom we see, to remind us, contingency tables, R rows, C columns. This is how many degrees of freedom. Now, say we're doing a goodness of fit test. So maybe we're trying to see if the number of automobile accidents is the same for every day of the week. So we've got the number of accidents, and we assume that accidents should be the same on every day of the week. And we've got here the number of categories, which is k. So 5 different days, and we'll get degrees of freedom equal to k-1 or 4. So our critical value for this particular test would be 4 degrees of freedom, critical value 9.488. So for this table, basically we've got 2 columns that we're using, the degrees of freedom column and the column for significance level of 0.05. And once we get our degrees of freedom, we'll go over here, find our critical value, and then as we have in other hypothesis tests, what we'll do is find a test statistic, compare it to the critical value. If it's greater than the critical value, we'll reject the null. If it's less, we'll fail to reject the null.